Only thing weird going on: random transitor star system. Stumps scientists. Strange star system reminiscent of the 2015 Tabby star event. A new enigmatic star, the random transitor observed by NASA K2, looks to have taken the title of the most mysterious star in the Milky Way. The Kepler Space Telescope captured a pair of stars collectively called HD 139,139, about 360 light-years away, that experienced 28 dips in their light over the course of 87 days, measurements that would normally indicate an orbiting system of planets, except that the timings of the dips appear totally random. The stars were spotted behaving strangely by the Kepler Space Telescope before it ran out of fuel and ceased observations. The dips in HD 139,139 light look like normal transits, all similar in size and shape. But when Andrew Vanderberg at the University of Texas at Austin and his colleagues took a closer look at the data, they found that their timings appeared totally random. The researchers concluded that no more than 4 of the dips could be caused by the same orbiting object. Been looking at stars with this kind of precision for about 10 years now, but this is the first time that we found something that looks like a transiting planet but has no apparent periodicity, says Hugh Osborne at the Laboratory of Astrophysics of Marseille in France. Only thing weird is going on, writes Osborne in his blog, Lost in Transits. The more you look and play with the light curve, the more you see something troubling. They are not periodic at all. Could construct for you a system of planets that would explain these dips, but it would be really contrived, says Vanderberg, concluding that there would have to be far more than any other planetary system we ever seen to just DOES and feel right. No plausible conjectures. Hugh Osborne describes several possible causes below in his Lost in Transits blog post. Why the random transitor is now the most mysterious star in the galaxy. A plethora of planets. If enough planets orbited the star, they could all be responsible for a single or possibly 2 dips. However, not only is it extremely improbable that 14+ planets would all be in transit and all have similar radii, they would be certainly on unstable orbits to produce such similar transit durations. This is also true if we suggest some planets are orbiting the smaller star B. And even if we assume the planets enter around a true period due to TTVs, they simply cannot wander far enough or be numerous enough to explain the data. So we can rule out classical planets. A disintegrating planet. As I mentioned above, a handful of objects have been found with dips that come and go, caused by a small planet in the process of being evaporated, sending out a cloud of dust which is eventually blown off. However, in these cases, there is still some degree of periodicity. The body may not cause a transit every orbit, but every time it does, it should happen at the same point in the orbit. Also, HD 139139 dips are seen to happen at a minimum 5 hours apart, but such an orbit is likely unstable, and also incompatible with dips that last longer than 5 hours. Dust-emitting asteroids. In some systems, bizarre aperiodic dips have been spotted that appear to be due to planetesimals that are undergoing evaporation, much like our disintegrating planet idea, but with multiple bodies. This is true for the young star RZPSC and the old white dwarf WD 1145. To me, this is a scenario that looks most similar. The dips can be transit-like but are not periodic, although in the case of WD 1145, they are often followed for more than one orbit, giving a periodicity. However, there are some problems with this idea, namely the fact that all of the transits here are the same depth. These clumps of asteroids should not all be producing exactly the same dust clouds in terms of both size and density. They should be far more variable. Similarly, how are these asteroids all on different, wide orbits at just the right orbit to produce so much light-blocking dust? Planets in a binary system. One way to avoid periodicity of planets is to place them in a binary star system. I guess in this case we mean in a triple system, with one of the 2 stars we see being a tight binary and a planet and the other not involved. In this case, the stars are moving, therefore not every orbit produces a transit, and they can have different durations but often the same depth. Sounds familiar, right? There are 2 ways to do this: place one planet around both stars, or place a planet around a single star. However, both options would require extremely short periods for both the planet and the binary to make so many dips, and the team could not find a stable system for either case which matched the data, and the radial velocity measurements rule out this being a binary system. A young Ypper star. These are young stars with random clumps of dust raised from the circumstellar dust disk into our line of sight, blocking up to 50% of the starlight. However, Even if this dipper behavior is happening on the fainter companion, it do not resemble at all what is observed from the random transitor. There is no periodicity, no out-of-dip variability, and all evidence suggests the star system is old and DOES and have any obvious dust disk which would show up as excess infrared light. Also, the asymmetric dips of these zipper stars really shouts lumpy dust to me, as does the light curve of the bizarre Tabby star. The dips of HD 139139, on the other hand, appears far more ordered and Lynette-like. However, these dipper stars are poorly understood, as I know well, and it is entirely possible we have found a bizarre new member of the group. Short-lived star spots. Another poorly understood part of exoplanetary science is that we don't know exactly what stars are capable of. On the Sunday star spots last week's, and sometimes multiple stellar rotations in this system, the star appears to spin every 15 days, but maybe there's some rare process where a star spot could bubble to the surface, depress starlight for a few hours, and then dissipate entirely. SETI, an alien megastructure? This option is not mentioned in the paper, but it is a system that is sure to interest those who are certain Tabby star is actually an alien megastructure. Not. If anything, the coherent dips in this system look more like solid structures than the incoherent wandering of flux during the eclipses of Tabby star, though the orbital periods the transit durations suggest don't really make sense for any solid structure. Some also suggested searching for pi or prime numbers in the signals. But if an alien was trying to get our attention and had the ability to build structures 1.5 times larger than Earth at random orbital periods YWOULD, and they just, send us a radio or laser pulse, to me, it makes far more sense that this system is some previously unknown natural phenomenon instead of relying on an lean of the gaps logic. But there will always be those who want to believe. In 2016, a group of astronomers from Pennsylvania State University released a preprint that cited star KIC 8,462,852 is a light curve as consistent with a swarm of alien-constructed megastructures. This ordinary F-star soon went viral as the most mysterious star in the universe, as Yale astronomer Tabitha Boyajian described KIC 8,462,852. Popularly known as Tabby's star. He dips found by Kepler are real. Something seems to be transiting in front of this star and we still have no idea what it is, said German astronomer Michael Hippke. But follow-up research led by Huan Meng, an astronomer at the University of Arizona, concluded that a microscopic dust ring originating from circumstellar material found in the star system is causing the dimming and brightening exhibited by KIC 8,462,852. T cannot be anything from the interstellar medium, says Meng, meaning the object S at the focus of this investigation is definitely within the planetary system of Tabby's star. In astronomy we have a long history of not understanding something, thinking it aliens, and later finding out it's something else, says Vanderberg. The odds are pretty good that it's going to be another one of those.